Hi everyone, welcome to our 8th community call bi-weekly. Very exciting time here because it's our final few weeks before we launch. Just so before that, there's a bunch of stuff that we have to go through. We'll be working with DesignDAO on some of our designs and our UX. We obviously need to get security audited, and we're doing a lot of design, redesigning and testing of our smart contracts. So smart contract developments are undergoing very, very rapidly, and it's been a crazy few weeks. So today, I think we wanted to announce / also share with you how at this stage, when we launch, VectisDAO is going to be a multi-chain DAO. So before, I guess, going back to our community cause, you'll see that when you create a smart contract wallet on the Juno testnet, you are given a GovVec token, which is a governance for Vectis token, and then you could use it to propose and vote if you've staked it. And so that's all happening on the Juno testnet. But when we launch onto the mainnet, we'll also be supporting proxy wallets to be deployed on another chain. So and also IBC communications between the remote chain and then the Juno network. So then people with proxy wallets on other chain, specifically now on T-Grade, will still be able to take part on the VectisDAO governance. So just to highlight specifically that the wallets, so the proxy wallets themselves are not IBC enabled. Everything goes through these tunnels, and we're basically going to talk about those today. So we have updated our repo on GitHub, in abstract Vectis on the wiki page. It goes through sort of the user usage and the roles, etc. But in general, it's being updated to also show the specifications of the contract. And there's also, like, as you can see on the screen, there's a design that has gone through to basically what we're building, so it's easier to illustrate. So on the left-hand side here, we have the DAO chain. What that means is where the DAO contracts are deployed, because we're leveraging the DAO stack. So we're building on still the V1 contracts because those have been audited, and we want to keep that as a target for now. And so we have our own version of the CW20 staking contract, which is the GovVec token, which right now is very simple. You could only transfer it to other proxy wallets, and it's not supposed to have at this moment like any sort of value apart from like voting. So you get one per wallet, and that's it. And then we have our own version of the stake balance voting, which is the voting module in the DAO contracts architecture, and also our version of the proposal. These versions are specifically used because of the tunnel design that we're going through now. So then on the DAO chain, we have the DAO tunnel, which is a smart contract that is very much inspired by the IBC demo that Confio has done on the repo, but also the ICA design that they've also demonstrated in the repo. And then going down, we then have what we did in our previous testnet launch, which is the factory and then the proxy, and also the multi-sig contract. And then now the exciting part is on the remote chain. So let's call this on T-Grade, we will have the remote tunnel contract, and then again the factory and the proxy. So let's go through sort of like the interactions of these DAO contracts, so then it's easier to discuss it. Cool. So when we create a the first thing that a user would do is obviously to go and create a wallet. So if you're on Juno or if you're on T-Grade, you would still we'll still provide an interface for you to create a wallet on that local chain. So the factory is something that is deployed on both chains. So the user would go ahead and create ask to create a wallet, and then everything sort of still happens the same. So if you want a wallet with multi-sig, we will do the same thing. And then the next thing that has changed is in our previous version, we automatically mint a GovVec token that belongs to this new wallet. In this case, because we're not because we're trying to give users sort of this option of like, do you actually, because you're on a remote chain, maybe you don't really care about what happens to the DAO on the Juno network or etc. So we're giving the user an option to see if you actually want to take part of this at all. So the factory basically stores this GovVec claim list, which allows people to claim in a future time before this claim right has expired, a token. And so in the remote chain, what happens is the user would then have to go and send a message to be like, okay, I want to claim my GovVec token now on the Juno network, and then it would go through the remote tunnel, and then the remote tunnel will sort of relay that onto the DAO tunnel, and then that would relay that to the GovVec. So the important thing here is that the CW20 version, the GovVec contract actually stores the addresses of the remote proxy as in the ledger of the balance. So that basically allows us to have people could still stake and have the same sort of native experience as having your proxy on the Juno chain. The only difference is that when you communicate, you go through these two tunnels. So this is slightly this might be a bit small. But so in diagram we have okay, that's great, thank you. So in diagram, the user basically claims requests to claim the GovVec. So the proxy the proxy address is already saved onto the factory on the claim on the GovVec claim list, and then the factory would check that have they claimed it before, etc. And on the DAO chain, very simple. If they are entitled to claim a new one, it will just sub message over to GovVec. It'll mint one, reply. Everything works sort of atomically. If there's a problem there, then everything just reverts back. But else on the remote chain, the factory basically pushes this proxy wallet address to sort of like a pending GovVec claim list, and then it starts to package this to send a IBC message to the DAO tunnel. And then once that's been relayed, the DAO tunnel would attempt to mint a GovVec for the user, and then everything if everything works well, then it'll reply. Actually, it doesn't matter if it doesn't even work well. It will still reply, and then we either basically remove this. If it's successful, then we remove the proxy from the pending GovVec list. If not, then we'll put it back into something that they could claim in the future. One thing to highlight here is that the GovVec sort of mint list has an expiration date. We don't want to be keeping many addresses around for forever, and so we haven't really decided, and would love to hear your thoughts on sort of like after you've created the wallet. Ideally, on our interface, it would just be immediately like claim your and join our VectisDAO. But there's probably a time where people could decide if they want to or not. And then I guess the final thing is when you now have your GovEx, you want to interact with the DAO. You first have to do you first have to do staking, and then you could then vote, and you could do propose. So these are sort of categorized under the umbrella of DAO actions, because the flow is very similar. You have the user want to do something, participate in the DAO. On the DAO chain, very simple, direct messages through the different contracts. On the remote chain, again, the user would forward a message to the DAO remote, to the remote tunnel, and then that gets relayed over at some point, and then it goes onto the DAO tunnel, and then the DAO contract executes that. There was some sort of worry in the design that, well, there's two ways of looking at this. Because they're on different chains, the fact that something happened on, say, the remote chain would not really reflect immediately on the DAO chain. And so in order to sort of to create a source of truth, for example, the staking power that someone has, or like how long have they staked? Are they allowed to vote at this block, etc.? That's all. The source of truth is on the DAO chain. And so when you're staking on the remote chain, like, you need to make sure that the message gets relayed, and then because the address of the remote proxies are exactly the same as on the remote chain, that would be, you'd have the same sort of rights as being a proxy that is on the DAO chain, and also the truth in terms of timing, when you state, when you could withdraw or claim, etc., is all, the truth is still on the Juno network. So we to make sure that the relayers are relaying messages back and forth to that. Another very, I guess, important, as you can see from this diagram, is the communication between the remote tunnel and the DAO tunnel. We need to make sure that they both recognize each other, and that they only execute messages from each other. And therefore, Javier is working on the deployment, but the steps are basically documented in the IBC, sorry, in the tunnels documentation. Sorry, Javier, can we go click on the tunnels on the that would work, I think. Yeah. So the setup requirements are written here. Basically, we make sure that channels could be created. That's not something that we could stop. But on both the DAO tunnel and also on any remote tunnel, we make sure that it's from a source that the DAO recognizes and authorized. So their light client on their chain is identified by a connection ID, and then the port ID of the incoming message is recognized by the WASM contract address on that chain. So these are the sort of identifiers that we use, and then the channels could be created on top of that channel. Just gets incremented, but we basically make sure that we check that these are this is from the source, and so we could sort of trustlessly execute things from an authorized list of tunnels. Right now, obviously, we're talking about having two networks, but the the remote chains there could be multiple, and the DAO tunnel would have multiple authorized tunnels to send them to execute these IBC messages. So really, you're welcome to come and visit our wiki and open any issues as you see fit. I think we're continuously trying to document this. And then at the same time, if you go to our repo, we're working on the IBC branch. And I think the contracts, we've taken sort of an iterative process. So we've sort of got enough to start testing with local networks, and so I'll leave over here to talk about that. And then we're basically finding things that we need to improve on, and then updating the specs, like updating the wiki of like why we made these decisions, and then also updating the contracts. Cool. So that's me. Javier, if you want to talk a little bit the process of deploying, etc.
Yeah,
And
thank
I
you.
know there's no code to share at the moment. It's all good.
Thank you, Elsie. Yeah, I want to share the details of deploy the tunnels in a local environment. So
Mm,
I create an script to sorry, I'm working in another branch, but it's gonna be merged soon. So let me this one. Okay, so I create a script to instantiate two Docker images. Which one is for Juno, another one is for Watson. It's run both chain with the necessary accounts. We have a different account for testing purposes. So it's necessary to run this script to launch the the local blockchains. Um, yeah, in the CLI folder in the core folder, we have the deployer and also the upload the the contrast for the host chain, in this case the DAO chain, what we call the DAO chain, and the remote chain. So when you run the npm command, npm upload, you have to pass it the different network, the different blockchain where you want to upload this contrast. In this case will be Juno local net, was on local net, and after that you can use the deploy DAO. The deploy DAO is a script where does all the process to create the with the relayer client. It's create the connection when the script initializes. Yeah, and after that instantiate all the contract, create the proposal to instantiate the factory in the other in the other chain, the remote chain, and also the channels. Yeah, that's pretty much the deploy script. So everyone can use this branch and test the functionality. I don't know if do you think I should add something, Belsi, I maybe miss in this part?
no, I guess I'd be curious to see when the relay, like at the beginning when the relayer runs because we so sort of assume in our contracts that there is already a like client.
Yeah, I know what you mean. There is pending, but I prepare a method to recover the connection.
Okay.
For local ones, we create the
Hmm.
always the connection. But
Hmm.
when we deploy in mainnet or testnet, we recover
Hmm.
the information from a JSON file, and that's the
Right.
information we use for the connection.
Okay, great. Yeah. Yeah. This is yeah. So I guess in the document we just highlight again here. We sort of assumed that there will already be like clients of different chains in the different chains already created with previous IBC connections. So, just curious when we run it. So when we run it the first time, we would create our new connections. Okay, cool,
Yeah,
awesome.
exactly.
Yeah, cool. I don't. Yeah, I also just want to, I guess, say, and we've said this before, is the design and the overall pattern of this, I guess, is because like obviously the proxy, the smart contract wallet itself could be IBC enabled. It could, and in the future that might be a version of something that we push. But and obviously depends on the community if they if that's something required or not. But in this version, like having these tunnels just means that we're not handling that we're not requesting users to like create a channel between their proxy to a service that they want to use every time. Instead, we provide like a place for all these IBC messages to go and then to be dispatched onto the host chain. Yeah, so this is sort of like the only place that has the IBC enabled code. And just I guess here as well. The on the remote chain when we just like we do now, when we create a wallet there's a fee, and this fee goes to the DAO, and then people could vote as to what this fee is going to be used for. And so in the remote chain, the remote channel actually also has a channel that connects to the IBC transfer module on Juno, and so the fee could directly be sent to the DAO CW core contract address, and so we'll be able to display sort of like all the different types of IBC transferred over assets from different remote chains that the DAO natively owns. So that would be pretty cool.
Yeah.
Cool. I don't know if anyone has any questions.